All right, thank you. Day 2 of first semester final review. We're working on corresponding alternate interior, relationships between parallel lines with a transversal. Let's talk about all of these. Corresponding. If I have two parallel lines with a transversal through the middle, if I start with X there, where is the corresponding angle to that? Up to the left? Yep. So they're both on top of their parallel lines on the same side. Okay. Alternate interior, two parallel lines with a transversal. If I start X here, where's the other X? Where's the other angle? On the other side, on the inside. Remember, if I drew my box, they're on the inside of the box, but on opposite sides of our transversal. If you think about it that way. Okay. Alternate exterior. Two parallel lines with a transversal. If I start my X here, where's my other angle that's alternate exterior to that? Sorry, I put that in the wrong spot. X here, where's the other one go? Yep, outside on the other side of the transversal. Same side interior. Inside on the same side.
Which is number 23, same side interior.
Okay, one more we gotta talk about vertical. If I have two parallel lines with a transversal, if I put X here, where's the other X? Right across from that intersection. Okay, any questions with those 5 vocab terms?
No.
Remember those?
Yes.
Okay, looking at 23, let's go through the process quick, okay? Remember drawing your box. Are they on the inside or the outside? Inside. Now I draw my line. Are they on opposite sides or the same side? Same side, so this would be same side interior. Looking at 25, what do we notice about that one?
Vertical.
Why are they vertical? They're right across from each other on the same line. Yep, on the same parallel line.
What if the X was left of the line? Would it be just the linear?
If it was right here, it would be a linear pair.
Okay.
Yep, good job. Any questions on those vocab terms?
Nope.
Okay, flip over to the next page. Now we're still dealing with those relationships that we just talked about, but now we're putting angle measures with it. Okay, so looking at 27, find the relationship first. What's the relationship between those two?
Same side, corresponding.
Corresponding. Okay, I feel like that's the hardest one to see. They're both on top of their parallel lines, and they're on the same side. So only option would be corresponding. Looking at these, do they look the same?
Yes.
Yes. So this, if one's 100, what's the other one? 100. They both are obtuse, so they are the same. Looking at 29, what's the relationship there? Interior's correct. Are they on the same side, though? Yep. Right here, this would be alternate interior. Do those look the same? So 105, is that acute or obtuse? Obtuse. Does the question mark angle look obtuse or acute? It looks obtuse, right? It's greater than 90. If I drew 90 in there, it's greater than 90. So since they're both obtuse, are they different or are they the same? The same. If one's 105, the other is 105.
Are you going to dock us on the final if we don't put the degree symbol?
No. 31.
Same side interior.
It is same side interior. What do we know about same side interior? They're on the same side, but are their angle measures the same?
No.
Why not?
They're not the same. They add 180.
They're on.
So this one, it looks obtuse, right?
Yeah.
This one, does it look obtuse? No, it's acute. So if you have an obtuse and acute angle, what do they add up to?
180.
180. So how would I set that up if they add up to be 180?
X plus 11x minus 6 equals 1.
Yep. Now, sometimes we struggle with these. Let's talk about it. Combine like terms. What are like terms on the left side?
31x.
20x and 11x are like terms. We're going to combine those. So add those together. We get 31x. And then rewrite what we have. What is my next step?
Plus 6 to 180.
Yep, we want to add 6. So I have 31x equals 186. Last step.
31.
Good. Divide by 31.
X equals 6.
X equals 6. I want to back up a little bit to find another example. Look at 28 quick. What's the relationship there on 28?
Same side interior.
Same side interior. Now, we just talked about those. What do those two angles add up to equal?
180.
180. So how do we find the missing side?
114 from the main.
Yep. 180 minus 114 to give you 66. Okay, so remember, they're either going to be the same or they're going to add up to equal 180 with these.
And same side exterior is equal 180, right?
There will never be such a thing, but yes.
What do you mean?
Same side exterior is not an option.
Yeah, no 30. Oh wait,
That's
opposites.
the-
That's
There you go. Yep.
So 30's. Gonna be
I'm not going to tell you. You'll do that one on your own, okay? 33. What's the relationship there?
They're corresponding.
Corresponding. Okay, are they the same or do they look different?
They're the same.
They're the same. So if you say they're the same, how do you set it up? Equal them to each other. We have 18x minus 1 equals 16x plus 13. Now, pay attention because sometimes we struggle when we have x's on both sides. Okay. From here, I want you to underline your x's. We want to get them on the same side, so I just want to move one of them. Doesn't matter which one you move.
No.
It doesn't. Which one do we want to move?
16.
Okay. Do I add or subtract it over?
Subtract.
Subtract 16x on both sides.
So you can keep it positive.
Yep. 18 minus 16.
2.
We have 2x minus 1 equals 13. Now we have x on one side. So now we can solve like we normally do. What's my next step?
Plus 1.
Add 1, getting x by itself. We have 2x equals 14.
Divide by 2, x equals 7.
Divide by 2, x equals 7. Now, if at the beginning you decided to take the 18x over, you still would have got the same answer either way. Okay?
No.
So remember, if you ever say something's the same or they're equal to each other, how do you set it up? If you say they're the same or they're equal to each other. If you ever say one of those two words, you set them equal to each other. Okay? Any questions on that page right there with those relationships? You have a question? 34? Okay, what's the relationship here? They're corresponding, so since you say they're the same, how would you set it up?
115 equals x plus 120.
Yep. Are you confused because it's going to be a negative?
Yeah.
It's okay if it's a negative. If you ever get a negative answer for an x, it's okay.
I didn't get negative.
I got a negative.
Because what would be my step here?
Subtract 20.
Subtract 120. So I would get negative 5 equals x. What's up?
To get an even number, I don't know.
How'd you
Did we get a
subtract
16 number here and
Because if I
16
subtracted 115, I would have it on the same side as x.
On the opposite side.
I want to get x by itself.
Why does it matter?
Does that make
which side
sense?
you take it from? I got it.
Okay.
I got it.
Good questions. Any other question on this page? All right. 35 and 36 are similar. Okay, let's go to 37.
Easy.
What does it mean for a translation? What does that mean? What's happening to our picture?
What about 35 and
It's
36?
the same thing as what we just did.
Okay.
What'd you say? You're moving it. Nothing's happening to the shape. You're just moving it across the graph. Okay? So we have this rule here. We need to break down this rule and decide what it means. So x plus 4. Which axis is your x-axis? Vertical or horizontal? Horizontal is your x. Vertical is your y. Bless you. Now it says x is moving plus 4. We want to go in the positive direction on the x. So what direction am I moving?
Right.
Right 4. So we're going to write the rule. We have right 4 to start. Then y plus 6. Y, you're either going to go up or down. If we're adding 6, do I need to go up or down? Up 6. So this right here that we just made up is our rule that says this exact same thing. Okay? Now, what do I do with that rule?
Move it right up, right four up six.
Every single point we're gonna, each point we're gonna use that rule. So on J, I'm gonna move right 4, 1, 2, 3, 4, and up 6. 1, 2, 3, 4, 5, 6. And then you're gonna do that to every point. So W, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6.
Which is labeled as
E,
prime.
1, 2, 3, 4, 1, 2, 3, 4, 5, 6. What was your question?
It's labeled as prime.
Yes.
Like, and like.
Yes.
E prime.
Can I leave it like that?
No, I have to connect the
Yep,
dots.
connect the dots. How can you check if you did it correctly?
Just do it backwards.
You can do it backwards. Check if it's the same shape. Okay, because really, should anything happen to our shape?
No.
No, it's just moving. It doesn't turn, it doesn't flip, it doesn't do any of that.
It's not mirroring.
I
Yep.
think I have COVID.
Any questions on the rule right there?
No.
If it said x minus 4, what direction would I move in the x?
Down.
Left.
Or left.
I would go left 4. If it said y minus 6, I would go down 6. Another thing I want to talk about, what if it had x plus 4 and then y? What's happening to our x?
Yeah.
It's just moving forward. It doesn't move any Y.
Right 4, and then your y, nothing's happening, so y stays the same. I'm just going to put same y.
Can we use our,
But, or Gabe, did you ask why?
No, I was making a joke since it's Y.
Oh, haha. What, Aiden?
does, can we use our, what's on these triangles?
Okay, any questions on translations
No.
with those rules? Okay. Classifying each triangle by its sides. What were those 3 different ways you can classify a triangle by its sides?
It's like
What if they're all the same? If all sides are the same, what's it called?
lateral.
Equilateral. What if 2 sides are the same?
Iso.
Isosceles. What if none are the same? So I have equilateral. And we said that was 3, 2, and 0. 2 we said was isosceles. 0, remember? Scalene. So all 3 sides equilateral, 2 sides are isosceles, 0 are scalene. So looking at 39,
Scaling.
scalene because
No angles or sides are.
no sides are the same, they're not given, okay? What about number 40?
That's isos.
Why?
Because it doesn't give us. It only gives us 2 numbers.
Right, it gives us 2 sides, so we can assume it's isosceles.
What about number 42?
Yep, let's talk about angles now. If we have 3 angles that are the same, do you remember the word for that?
Equal angular.
Equiangular, good. And then, let's talk about it. 41, what's our answer?
Equiangular.
Equiangular because
All three are the same.
all 3 angles are the same. 42, what kind of angle do we have in there?
92.
We have a 90, so what's that triangle, Carl, if you have a 90-degree angle?
Triangle.
Right triangle is what you want to call it. Right triangle. So automatically, if you have a right angle, you are going to have a right triangle. Okay? Any questions on this page right here?
No.
Wait, I have a question.
Okay.
That's enough.
Okay, that's the farthest we're going to go, so do not work ahead.
What did you get for number 35 or did you do 35?
Remember, answers are on the back of your review.
Oh, okay.
36, you had a question?
So we're
It
just.
don't make sense. I gotta
Okay. What's the relationship on 36?
correspond.
Same
same time.
Same side interior. Okay, good. Now, do they look the same or do they look different? Different because one looks obtuse, one looks acute, right? So what do we know if we have an obtuse and acute angle? Add them together, set it equal to 180. So tell me what I need to write.
96 plus 6 plus 60 equals 180.
plus 60 equals 180. Yep. So if we get here, we want to underline our like terms. So we have 6 plus 60. So we get 19x plus 66 equals 180. Is this step making sense, or do I need to slow down a little bit? We're okay? What's my next step here?
Minus 66 from 180.
Subtract 66 on both sides. What's 180 minus 66? What?
Wait, 180 minus 60?
Yeah.
That's
114.
114.
And then my last step would be to divide by 19 to get 6. Better?
Yeah.
Okay, any other questions over any of this?
Is that it?
Okay, that's it for day 2.